this is example 3 in the textbook. And again, we're using that limit notation. We're saying, what's the limit of this function if I let x approach 0? Well, what would I get if I tried to actually plug in 0 for x? I'm going to get 0 in the numerator. I'm going to get the square root of 0 plus 1 minus 1 in the denominator. And that is 0 over 0. It's definitely undefined. So this does not have a value at that point. So one of the ways that you can determine what it looks like the value would be, but this one is definitely not like the other one, which is a very clean linear function, y equals x minus 3. You know, we don't really know what this graph would look like, but let me load it and you'll see. That was example 3. All right, I've got that function here, and this is what the graph looks like. It starts at x equals -1, kind of looks like a radical function going off to the right. But what do we notice at x equals 0? There's an error, because we know that if we plug in 0, we get undefined. So the function, even though it looks like it's a continuous line, looking at it on the calculator, there's actually a hole in this right there. Okay. So how can we figure out what the area is? Or, sorry, the value is right at that point? If you look in the table of values, you could see that the value before 0 is 1, and the value after 0 is 2.4142. You know, what if you just took the average of those two? What do you get if you add up 1 plus 2.4142 divided by 2? What did we get? 1.70 something? Okay. Now, do this with your calculator. You know, here we were taking increments of 1 here, right? It goes -2, -1, 0. Let's try to make it go tenths, not just whole integers, but tenths. So go into the second table and let's set this to, I'll have it start at -0.2, and now it's going to go every 0.1. And let's see what it does to the table. Second table. Okay, so now the value before is -1.9487. The value after is 2.0488. Why don't you try to take the average of those? Do we get the same thing, or do we get a little better answer? Okay, take the average of these two. So 1.9487 plus 2.0488 divided by 2. What is that? 1.99? Okay. So it's getting very close to 2. Okay. Let's go back to the calculator again. What if we make the increment instead of 0.1, let's make it 0.01. Second table, so I'll make this -0.02, 0.01. Look in the table. Okay, now it is the value before is 1.995. The value after is 2. Why is that not going? Plus 2.005 divided by 2. And what is that? It looks like it's 2, isn't it? So it looks like because this graph right? Because this graph, it looks like, it's not like going completely different directions. It looks like it's going right to that point. Except for the one hole that's there, it would have been continuous. And it looks like it's approaching 2 from the left and from the right. So we would say that the limit of this is 2, right? Like say, you may have to keep making the delta less and less so that it really is giving you something that's more accurate.